So 3.10 is about inequalities, polynomial inequalities specifically. So here, if we're looking for where is m of c less than or equal to 0, remember m of c is the same as y. So we're looking at our y-axis here. And I want to know where is y less than 0. So that's going to be any place that it is under the x-axis, or since it is less than or equal to 0, or on the x-axis. So this one is on or under the x-axis in between -3 and 1. -1. Between -3 and -1. Now, had they asked you where is that greater than 0, then you would have been looking for all of the places where it is above the x-axis and not on the x-axis. So this function is greater than 0 from -infinity to -3 and -1 to infinity. Notice that this did not have the or equal to, so these were both parentheses. This did have the or equal to, so these were both brackets. Okay. So when you are solving a polynomial inequality, we have these steps to go through every time. And that is, first, we're going to take our factored form and find the values where this polynomial would be 0. So here we know that would be 1 and 8. Right? If I say x minus 1 equals 0, that would be 1. If I say x minus 8 equals 0, that would be 8. So then I draw a number line, which here they already gave me, and then I put dots on the number line at these values. So a dot at 1, a dot at 8. Now note that these are closed dots because this did have the or equal to. If it did not have the or equal to, then they would have been open dots. Now, putting these dots in, I've essentially cut my graph into 3 sections. The section less than 1, the section in between 1 and 8, and the section greater than 8. And what I'm going to do is I'm going to take a test value in each one of those sections, and I'm going to plug it into my equation and see whether my answer would be. Now here I'm looking for a number less than 0. So let's start by testing 0. We're going to test a number on this side of my number line, and we'll choose 0. 0 is usually the easiest to choose. If I can choose it, I do. So I'm going to do 0 minus 1 and then 0 minus 8. And I'm checking to see, is that less than or equal to 0? So I'm going to get -1 times -8. Now here, at some point, the actual numbers that you're looking at don't matter, only their signs do. So I'm multiplying a negative times a negative. So that means that my answer would be positive. And is it true that a positive value is less than or equal to 0? No. So when I plug in 0, my inequality is false. Now I'm going to test a number in between 1 and 8. So I can do any number here in between 1 and 8. I could do pi if I really wanted to, but let's do 2 because that's probably going to be the easiest. And again, I'm looking to see whether or not I'm going to get something less than or equal to 0. So 2 minus 1 is 1. 2 minus 8 is -6. And again, this time I have a negative, right? Positive times a negative. So I'd have a negative, which is less than or equal to 0. So that means when I plugged in 2, my inequality was true. And if your inequality is true, then you shade the line in on that section. All right. Now let's test a number greater than 8. How about 10? So 10 minus 1, 10 minus 8. That's going to be 9 times 2, which is going to be positive. And so this is false. So when your inequality is false, you do not shade the line. When it is true, you do shade the line. And now once you've checked all of your sections, you look at your number line and you write your interval notation based on that number line. So here I would say that my solution would be from 1 to 8. All right. So we're going to do the exact same thing here. Only obviously we have to do it all by hand. So here I have W equals -6, W equals +7, W equals +6. I'm going to put open dots at each one of these this time because this does not have the or equal to. I need open dots over here. And so I'm going to plug in a number from each section, 1, 2, 3, 4, and check to see this time I'm looking, will I get a number greater than 0? So we can start by testing a number that is less than -6. How about -10? And a note that any number less than -6 works. You could do -7, you could do -10, you could do -100. Any of those is fine. So I would do 4 times -10 plus 6 squared, -10 minus 7, -10 minus 6. So I'm going to do this one 2 ways. I'm going to do this sort of abstractly, and then I'm going to do it more concretely, and then you can decide which one you like. But 4 is a positive number. Anything squared is going to be a positive. -7 minus 10 is going to be a negative. -10 minus 6 is going to be a negative. Positive times a positive is positive, times a negative is negative, times another negative is positive. And is it true that a positive number is greater than 0? Yes. Okay. Now that was my super abstract way to do these. I think it's the fastest way. The more concrete way, so let's pick a number between -6 and 6. I'll do 0. The more concrete way would just be to grab your calculator and plug in. 4 times 0 plus 6 squared, 0 minus 7, 0 minus 6. Did I get a positive number? Yes, I did. So I'm going to shade in this section as well. Okay, now I need a number in between 6.5 and, or 6 and 7, excuse me. So I'll do 6.5. So I'm not going to shade in that section of the graph. And then my last test value will be a number greater than 7. How about 8? So I'm going to shade in that section of the graph as well. And now let's turn this into interval notation. So I would say all of the numbers to the right of -6, in between -6 and 6, and greater than 7. Okay. So if they give you standard form, then just factor. So here I'm going to get everything on one side, v squared plus 11v plus 30, and make that v plus 5, v plus 6. So v equals -5 or v equals -6. This does have the or equal to, so I'm going to do a close dot. And I'm looking for greater than or equal to 0. So let's test a value less than -6, so -7. So let's shade that section. Let's test a value in between -6 and -5. Oops. False, so I'm not going to shade that section. Let's check a value greater than -5. 0. I'll shade that section in as well. And so then in interval notation, this one would be -infinity to 6, -6, excuse me, -5 to infinity. All right, let's do one more of these. So I want my u to the third to be positive, so I'm going to move it over. But it's easier for me to think about it if the u is on the other side. And I'm allowed to move the u over as long as I flip the sign also. So see how it's open toward the 0 on this side? So I just have to make sure that it still opens toward the 0. So we're back to looking for values less than. Let's factor this. U. There we go. So two numbers that multiply to 36 and add to -15, that's going to be a -12 and a -3. So my numbers on my number line are 0, 12, and 3. This has the or equal to, so they get closed dots. Start testing, so we'll test -1. So that worked. So let's shade in that area. How about 2? 20 is not less than 0, so I'm not going to shade in that section. Okay, how about a number in between 3 and 12? So that, let's do 5. And again, you could pick any number in between 3 and 12. It doesn't matter which number you picked. Negative again. So let's shade in that section. And then last but not least, let's check a number greater than 12. So how about 15? Plug in 15. 15 minus 12, 15 minus 3, 540. Oops, so I'm not going to shade in that section. And so then I'm going to turn this into interval notation. Negative infinity to 0. And 3 to 12. Okay. We've done absolute value inequalities before, but it's been a while. So let's review our rules. First of all, you should always isolate your absolute value sign first, which was done for us here on the first example, but not on the second. So we don't have to do any extra steps on the first. My absolute value is already isolated. And then once you have your absolute value isolated, if you have a less than, then you turn it into a conjunction. You take this number, hop it over to the other side and make it negative. One long inequality. And then whatever we do to the middle to solve for r, we do to the left and the right as well. Now, if this had an or equal to, I would have included an or equal to on this side. And so just turn this into interval notation. You're done. And so then for the next one, before I can worry about the inequality, I have to get the absolute value by itself. So I'm going to do that by subtracting this 6. 40. And then dividing this 8. And now that my absolute value sign is alone, when you have a greater than, you split this into 2 separate inequalities. 9b plus 4, you flip this sign and you make this negative. And then you keep it for the other one. You solve each one of these separately, so I'm going to subtract the 4 and divide by the 9. Same thing over here, subtract the 4 and divide by the 9. So negative infinity to negative 1. Okay. So those are our polynomial inequalities.